Hey everyone, it's MG from Computer Science 315. As we're getting closer to the final exam, I'm getting a lot of questions, and I'll try to sort of make little videos, or if they don't warrant videos, I will do my best to put those in Moodle announcements regarding the answers or the explanations or discussions around the questions I'm receiving. I received a question asking if I could go over nested RAID levels or RAID combinations. So I thought it would be a good time to just kind of redo a part of the RAID, part of the storage discussion, specifically around RAID. So we had single disks and everything. That's already, we already have the storage presentation, storage lecture about that. So definitely go back and take a look at that. But in reference to RAID specifically, and eventually combination RAIDs, and I've actually added a little bit here. It doesn't change data that's already been out there, so you could still study that and pass the thing and know the material. But so looking at RAID, we originally looked at RAID and said it was a redundant array of independent disks back in the past, but that's whenever they were really expensive, and now it sort of also stands for a redundant array of inexpensive disks because they're relatively cheap if either of these are correct. So when we look at RAID, we primarily want to do some type of data distribution over multiple disks, and we do this to achieve certain goals, right? We want to achieve an increase in capacity. Maybe we want to say span all of our data across multiple disks, and as a result, combine all of those disks. Within reason, combine the data capacity together to get more capacity. We want to achieve some sort of redundancy, which means resiliency. We want to have failover, so we could lose a disk or two or three or X number of disks and still have our data at the cost of capacity, of course. And then we want to increase performance potentially, where we want to maybe distribute our reads or our writes across multiple physical volumes, physical devices like disks, to kind of not it's still probably the bottleneck, writing to disk, but the bottleneck is so much faster than it was before because we are writing or reading in parallel. Configuration all occurs on RAID controllers, which can be physical cards that all your disks connect to. Alternatively, we could use software RAID, which is also available and preferred in a lot of cases because hardware controllers can fail. Hardware controllers used to be like really big deals whenever software RAID was less developed than it is now. But now that software RAID is very, very developed, unless you have a really top tier server scenario, you're okay, I think, to use software RAID. We're going to go through the different RAID levels real quick, and I'm not going to spend a ton of time on these because we have this is just a supplemental piece mainly for combinations of RAID. So this is RAID 0 striping, and there's no redundancy there. Capacity is increased to the sum of all disks, usually the sum of the smallest disk, actually. So ideally, you want to use all the same size disks, so it will be the capacity of the sum of all disks. But sometimes you have a disparate allotment of disks, and it will just only use n times the smallest number. So we use this to increase performance. You can see we have two physical hard drives right here, 10 gigabyte hard drives, and it just will interleave, not necessarily interleave into the rated disks, but you get the idea that we're reading and writing to two separate disks. We can do this with 3 disks. The minimum number of disks for a RAID 0 is 2 because we need at least 2. But the math works out so that actually a RAID 0 disk and a single disk, the math is the same on them if you only have one. But again, a RAID is a redundant array, so A as an array, and array means multiple. So they can be different sizes, but smallest and performance increase in time the disk read slash write rates. And again, it's the slowest write rate. So RAID 1 is mirroring. We need 2 disks for this, and that provides n-1 redundancy. So you can have more than 2 disks. You need at least 2, but you can have more than 2. But you will always have n-1 redundancy. So if you have 2 disks and 2 minus 1 is 1 disk, you could lose 1 disk. If you have 8 disks, 8 minus 1 is 7. So you could lose 7 disks. This is really awesome for resiliency and read performance, but it's sort of just normal write performance. It's actually got to write to a bunch of places all at once. But and I say standard, probably it's actually diminished, but we'll just call it standard for now. Because sometimes depending on the controller you have, you might be able to eke out some performance boost there. But it's terrible for capacity, right? You know, we have 10 gigabytes, 10 gigabytes for disk one and disk two. You only have 10 at your rated disk level. No matter what, you will still only have that one disk's amount of capacity, no matter how many disks you add. You know, you could add 3 disks, you still only have 10 gigabytes. You don't have 20 or anything. That's something different, right? That's RAID 5. Where you have a minimum of 3 disks, single disk redundancy. You utilize parity bits, which are the binary Boolean math here, or binary math down here, XOR. They increase read performance in -1 disk read rates because one of those disks is worth a parity bit, right? So it's not one disk specifically, though they do have RAID versions that are like that. This is the striped parity, so the parity disks are striped, sort of barber pole fashion. And then decreased write performance because we have to do a bunch of operations to do writes. And the performance is impacted during rebuild. We don't want to do that. We don't want to use RAID 5 very much now, because if you had to rebuild, say you lost disk 3 and you put a new one in and you were rebuilding disk 3, potentially if disk 1 or disk 2 failed, you've lost all your data. Probably. I mean, maybe you could recover it, but probably not. So what they did was they added another disk on for resiliency. So you have minimum of 4 disks for RAID 6. It's called dual stripe parity. Still barber pole. We just have 2 parity bits for each layer there. And you have to dedicate 2 drives to parity bits, so it's n-2 usable space. So if you have 4 10 gigabyte disks, you only have 20 gigabytes usable. And this is recommended over RAID 5 if you can stomach it. So this is where we start talking about RAID combinations. This is the new slide information. For instance, let's say I have a RAID 6, 4 10 gigabyte drives, right? So it was this scenario where we have 20 gigabytes usable. So 4 times 10 gigabytes, 20 gigabytes usable in this RAID 6 drive right here. We could have made a RAID 0 or a RAID 1 or a RAID 5 or a RAID 6 with this because we have 4 drives, and RAID 6 is the largest minimum requirement of 4 drives. So RAID 1 or RAID 0 could have been 4 drives all in sort of RAID 0. It would have been 40 gigabytes of capacity, but no resiliency. RAID 1 could have been a RAID 1 of 10 gigabytes, and there would have been 3 disks resiliency, but not not a lot of capacity. A RAID 5 we could have done that would have been 10, 10, and 10, and then 1 disk for resiliency, so it could have been 30 gigabytes of usable space. And then the RAID 6, which was 20 gigabytes of usable space. So again, we wanted redundancy, and redundancy is in 1, 5, and 6, and resilience or capacity is in 0, 5, and 6 as well. So again, additional drive for redundancy instead of RAID 5, safety net during array rebuilds, 2 drive redundancy, 20 gigs of usable space. So let's go ahead, and we're trying to achieve a RAID 60. We haven't talked about RAID 60, but I think we were talking about RAID 51 or 15 or whatever in a previous, maybe in the exam. Just understand this is nested RAID levels. I'm going to show you how to calculate it kind of with a different set of images, and so you can do it for the exam. So let's take this RAID 60, RAID 6, and let's say instead of 4 drives, we've got a larger system. We actually have 16 drives, and we decide to make 4 RAID 6 arrays. So we have a RAID 6 of 4 10s, a RAID 6 of 4 10s, 4 10s, 4 10s. So again, this has 20 gigabytes, 20 gigabytes, 20 gigabytes, 20 gigabytes usable across all of these 16 drives. For a RAID 60, what we would do is we'd wrap each of these RAID 6s into a RAID 0. Notice RAID 60, the 6 is right here and the 0 is right there. So this is what your underlying RAID level will be, your nested RAID level, and then the 0 is what your outermost RAID level will be. So in this case, RAID 0 of 4 times the usable space, which is 20 for each of these. That means since RAID 0 is spanned data and we don't have any sort of resiliency, we don't have to worry about losing disks here. We have to worry about losing disks, but each of these can lose 2 disks, so we're reasonably safe. This would be 80 gigabytes usable across 16 10 gigabyte drives. So think about that. 80 gigabytes usable, 16 drives total. This is half of our usable space possible, right? We're using 80 gigabytes of potentially 160 gigabytes, but the good thing here is that the RAID 0 will contribute to the speed, and capacity, because using these individually, we would have had, 20 gigs, 20 gigs, 20 gigs, 20 gigs. Now we just have all 80 gigs in one place. Also, it can write to each of these separately, and it can do a lot of fast math, a lot of fast transfers between them, relatively fast. Let's this is all like theoretical, right? But relatively fast between them. And inside of each RAID 6, that data is being parodied and protected every 4 drives. So we could lose, these two, drive 1 and 3, and then drive 2 and 4, and drive 2 and 3, and drive 1 and 4. We could lose up to 8 drives in that 16 drive system. Half of our drives in the 16 drive system, but it would be 2 in each array. So eight drives in a system being out all at the same time, that is a remarkable achievement, negative achievement. However, notice the problem here, right, is if we lost any of the drive, if we lost 3 drives in any of these at one time, we've lost all our data because it's a RAID 0, right? So we still have the constraints of the lowest. If we lose any of this, if we lose this entire RAID 6 array, this RAID 0 is dead because RAID 0 doesn't have any resiliency. So, and again, sort of the RAID combo, RAID nested RAID bit right there. It's the you could do 2 RAID 1s. This is a RAID 10, right? So 1 is the innermost RAID. So this is a RAID 1 and a RAID 1 of two 10 gigabyte disks. So we have a RAIDed disk of 10. And then this is the 20 gigabyte RAID 10 disk that would write to each RAID 1 array back and forth. I hope this helps kind of clarify some of the RAID combo levels there. I mean, the idea here is that the first number you see, that's your innermost. The next number you see is your outermost, and you can actually even have a third. I mean, if I wanted to have like RAID 601, I would do I would need 32 drives, but I could do this exact same thing again, create 2 of these RAID 60s, and then RAID 1 them together. So I would have I would be able to lose 16 drives in in my system, and be able to still make the data work, still make it work. So if you have any questions, mg@southeastern.edu. Send the questions to me as soon as you can if you have them, and I will do my best to make a video, or at the very least do a Moodle announcement, or if it's something that's very particular, I'll send a reply back to you. So thank you for your time, and have a good day. Bye.